Hi there, Mr. Sutton here with the IM3 Honors 3-2 Extra Practice Solutions on adding and multiplying complex numbers.
To subtract these complex numbers, we have to first get rid of the parentheses. So first parentheses you can pretty much lose for free. You're just multiplying it by an invisible positive 1. So this is just 9 minus 6i. The next parentheses, you're really multiplying this by negative 1. So we have to distribute that first. So we'll have a negative 1, and then we have a negative 4i. That negative gets distributed to both of those terms. And from this point on, we're just combining like terms. So we have 9 plus negative 1 is positive 8. And negative 6i minus another 4i gives us negative 10i. To add these complex numbers, we just need to get rid of the parentheses and combine like terms. So we've got a 4 plus 2i. And this is really a positive 1 being distributed here. So this is still going to be a negative 7 plus 2i when that parentheses is gone. Combining like terms, we have 4 plus negative 7, that's negative 3. And then 2i plus another 2i gives us positive 4i. To subtract these complex numbers, we need to distribute and combine like terms. First parentheses, we can lose for free because there's just a positive 1, invisible 1, being multiplied by that. So just negative 3 minus 2i. This next parentheses, we have to multiply everything in here by a negative 1 because of this negative here. So this is going to be a plus 6 plus 4i. And now combining like terms, negative 3 plus 6 gives us positive 3. Negative 2i plus 4i gives us positive 2i. To add these complex numbers together, we first have to simplify these higher powers of I. Now remember that each of these goes in a cycle of 4. The exponents go in cycles of 4. So let's start by dividing each of these exponents by 4 to see what the remainder is, to see where we are in that cycle. 32, if you divide that by 4, 4 goes evenly into 32, so that's a remainder of 0. So I can rewrite this as 74i to the 0, because I to the 0 and I to the 32 will have the same value. And 21, dividing that by 4, we get a remainder of 1. So we can just write this as 32i to the 1 that we're adding in there. And then 74, dividing that by 4, gives us a remainder of 2, because 4 goes into 72. So this is really minus 21i squared. Now let's simplify just a little bit more. I to the 0 is just 1, so this is really just 74 for that first term. I to the 1 is just I, so we can write plus 32i. And then I squared is really negative 1. So if I'm already multiplying that by negative 21, I now have a positive 21. And then combining like terms, the 74 and the 21 are both real numbers, so we can combine those. That adds up to, 95. So we have 95 plus 32i. For this one, we're multiplying these imaginary numbers together. So we just multiply the coefficients and do exponent rules on the i's. We've got negative 56 if I do 8 times negative 7. So negative 56 I squared, because I times I is I squared. But wait a sec, I squared is really negative 1. So this simplifies then to positive 56. For this problem, before I can multiply radicals together, I first need to take out the i's caused by those negatives inside the radicals. So I'll rewrite this as negative 4i radical 2 times 5i radical 50, positive 50. And now I'll just multiply the stuff outside and the stuff inside. On the outside, I have negative 4i times 5i. That's negative 20i squared. On the inside, I have 2 times 50, so that's going to give me a radical 100. So let's see here. I squared is really negative 1, so this is really positive 20 out there. And square root of 100, of course, is 10. So we're multiplying 20 by 10, giving us a grand total of 200. Multiplying these complex numbers together, one way to do this is to FOIL this out. But now you may recognize that we actually have conjugates here, basically a plus b times a minus b. In that situation, we can just use that a squared minus b squared shortcut. So squaring the first term gives us square of 7 is 49. Squaring the second term is going to be 16i squared, and then we always subtract that second term in this situation. But we can go a little bit further because we know that I squared is negative 1. So this is really 49 plus 16, because you've got negative 16 times negative 1, so plus 16, and that leaves us with 65. To multiply these complex numbers together, we have to FOIL this out. So 2 times 3 is 6. 2 times 3i is going to be 6i plus 6i. And then we have 4i times 3 for 12i. Finally, 4i times 3i, that's going to be 12i squared, I times I, and that's positive. Now we're going to combine some like terms and simplify powers of I. So this 6 right here is going to stay the way it is for now. 6i plus 12i is 18i. And then we have an I squared. That can be simplified to negative 1. So this last term is really negative 12. And then 6 plus negative 12 simplifies to negative 6. So we have negative 6 plus 18i. On this problem, we're trying to square this complex number, which basically means doing 2 plus 5i times another 2 plus 5i. So you could write out that parentheses twice and FOIL it out. But there's another way to do it. You might remember a plus b squared, that format. You always have an answer that's in the format a squared plus 2ab plus b squared. So I'm going to use that little shortcut here, but you'll end up with the same answer if you write the parentheses twice and FOIL it out. So using my shortcut, we square the first thing. That gives me 4. Multiply these together and double it for the middle term. That's the 2ab part. So 2 times 5i is 10i. Doubling that gives us plus 20i. And then we square the second thing. That's going to be plus 25i squared. Well, I squared is really negative 1, so this is really a minus 25 we have over there. 4 minus 25 combines to negative 21, and we still have that 20i kicking around as well. On this problem, we're given that x has a value of 2i, y is negative 4, and z is 3i. Based on that, we want to try to take the square root of x cubed yz. Well, we're going to start by replacing the variables with what they stand for. So this can be rewritten as the square root of, now we have parentheses 2i cubed times negative 4 times 3i, like so. All right, at this point, before I do anything else, I'm going to simplify this third power exponent, because in PEMDAS, exponents come before multiplying. So I can rewrite this as, let's see, 2 cubed is 8, and I cubed is, well, just I cubed. So this is 8i cubed inside there. That was the only change I made so far. Now that I've done that, I'm going to go ahead and multiply together these terms inside the radical. So I have 8 times negative 4 is negative 32, times 3 is negative 96, and then I cubed times I is I to the 4th. So we have the square root of negative 96, I to the 4th. I to the 4th, I know, is really just 1, because if you divide 4 by 4, you get a remainder of 0. I to the 0 is 1. So this is just the square root of negative 96 times 1, or just simply negative 96 in the square root. Now I know to simplify that I have to take out that negative as an I. So I'm going to rewrite this as I radical positive 96. And you still have to simplify 96 because there's perfect squares that go into that. So I can split that up into 16 times 6. The square root of 16 is 4. So this is really 4i radical 6, which gives me answer choice C.